We're going to talk about the different ways that matter can be classified. Now, I know in the previous slide I said matter has chemical changes, physical changes, chemical properties, physical properties, and we can classify matter based on that. But we can also classify matter by how it's put together. So that's what this video is about, taking matter and looking at how it's actually put together. So the first thing we're going to look at are mixtures. Then later in the video, we'll look at substances. Now we can break mixtures apart into two different groups. You can have homogeneous or homogeneous or heterogeneous. Then we'll classify substance as either an element or a compound. Now, a mixture, like the word says, mixture, it's a mix of stuff. It's not the same stuff. You have different things mixed together, but they're not bonded together. They're just mixed together, you know, like a jar of coins. You could have dimes and pennies, and it's a mixture of coins. In this picture, I have a mixture of elements. Remember, an element is made up of one type of atom, and you could have different atoms stuck together, bonded together, fused together, but it's still an element because it only contains one type of atom. So in this picture, I have a mixture of element purple and element pink, and they're mixed together. They're not bonded together, they're just mixed up. This picture again shows a mixture. It's not the same stuff. In this mixture we have a compound. You can tell it's a compound because if you recall, compounds are made of different atoms fused together. They're bonded together. And then we have element pink. So this is a mixture containing a compound and an element. In this picture, I show element A, which are all blue, mixed with element B, which are all red. So we have an element plus an element gives us a mixture of A and B. They are not bonded together. They're just all mixed together. So the types of matter, the way we can classify it by how it's put together, we have mixtures and substances. Now I've only talked about what a mixture is. Now I'm going to break mixture down into homogeneous or heterogeneous stuff, homo or homogeneous, and then heterogeneous stuff. And then we'll look at the difference between substances, and those are elements and compounds, and we've kind of already covered those. I'll just review those quickly. So again, starting off with our mixtures, homogeneous or homogeneous mixtures. These guys look like they are the same all the way through it. So So if you look at red, yellow, green, blue, purple stuff, they look like they're the same. So from like our big perspective, they're the same. But if you look at the atomic perspective, it contains different stuff. Another word for homogeneous mixture is a solution. And vinegar is a really good example of a solution. It's not all the same. Vinegar contains the compound water plus the compound acetic acid. They're not bonded together. They're mixed up. But if you look at vinegar, pour it into a jar, it looks like it's the same all the way through it. That's why we call it a solution. So take a look at this picture. Is it a solution? Is it a homogeneous mixture? Yes, it is. And one way you can tell when looking at the atomic level whether or not it's a mixture is there a nice even pattern. That's pretty much what you want to ask yourself. If there's a nice even pattern, then yeah, it's a solution. It's a homogeneous mixture. Take a look at this one. Would you call it a mixture? Yes, the key is actually a mixture. We call a solid homogeneous mixture an alloy. In this case, an alloy and a solution mean the same thing. It is a solid solution. So you could say an alloy is a solid solution. This is actually brass, and brass is a mixture. Looks the same all the way through it, but it is a mixture. Brass, a mixture. Would you call this a homogeneous mixture? No, I wouldn't, because there's not a uniform or even pattern. So there's no even, try that again, even pattern. So no, this is not homogeneous. It is a mixture, but no, it is not a homogeneous or homogeneous mixture. So far, we've looked at mixtures. We haven't looked at substances yet. Mixtures, we've looked at homogeneous mixtures. They have a nice, even, uniform pattern, and from our perspective, they look the same all the way through it, even though they're not. We're going to now focus on heterogeneous mixtures. Then we'll look at substances, elements, and compounds. But first, let's look at heterogeneous. Even from our big human eye perspective, we can clearly see that a heterogeneous mixture is not the same all the way through it. There are different properties in different parts. In this picture, if I were to take a spoonful from the top and a spoonful from the bottom, I would get different stuff. There's different properties in different parts. A cookie is an excellent example of a heterogeneous mixture. Now, I'm kind of strange because I like chocolate chip cookies without the chips. Strange, huh? All right, yeah, I know I'm strange. Now, let's take a look at this one. Trail mix, clearly heterogeneous. You can see there's different stuff in different parts. Another example of a heterogeneous mixture. If I were to take a spoonful from this section or a spoonful from this section or one from this section, it's going to have different parts, different stuff. Oh, my arrows stayed. Again, heterogeneous. Notice it has a nice uniform pattern. Yes, we have a layer here and a layer here and a layer here and a layer here, but if I took something off the top and something off the bottom, I'm going to get different stuff. So now we're going to play a game. You guess, homo or hetero? Well, if you said hetero, you are right. There's different properties in different areas. Homo or hetero? This one is hetero. Make sure you write those down underneath the pictures, by the way. Yes, this is hetero. You have different properties, different stuff mixed together. You can see it's different. Kool-Aid. It is a solution if it's made correctly. You shouldn't have stuff floating around in it. It has different properties. No, I said that wrong. It has the same properties all the way through it. It is homogeneous. It is a solution. This one is homogeneous. It has the same properties. If I took a spoonful off this layer, or this layer, it would have the same properties in the same areas. Let me erase those so we can move on to the next video. Oh, and I'll erase this one. So is it homogeneous or heterogeneous? This one is hetero. You have different stuff here and different stuff here. It's not a nice uniform mixture. Homo or hetero? Yeah, it's hetero. You can see clearly that there's different properties in different stuff. Wonder what this one is. Homo or hetero? I would call this one hetero. It looks like there's different properties in different areas, not the same stuff all the way through it. Homo or hetero? Yes, this one is homo. It has the same stuff all the way through it. Homo or hetero? I would definitely call this hetero. You have different stuff here, different stuff here, different stuff here. It's not uniform. What do you think about this one? This one is neither homo or hetero. It is made up of exactly the same compound. This one is actually a substance. It is not even a mixture. A substance is pure. A lot of times you'll hear people say, well, it's a pure substance, which is redundant. It's, the same thing. If it's pure, it's automatically a substance. If it's a substance, it's automatically pure. It has exactly the same thing all the way through it. Yeah, it's the same. It's pure. Iodine is made up of two iodine molecules fused together. It looks like this. Two iodine molecules, two iodine molecules fused together. And a whole bunch of those makes a pure, pure substance. It's redundant. It's a substance because it's pure all the way through. This is made up of all of the same atoms, so it's a substance. This is chlorine gas. It's pure. It's made up of the same thing all the way through it. Its chemical formula is Cl2. Two chlorine atoms fused together. It's the same stuff. Here we have another substance because it is the same thing all the way through it. Even though those atoms are bonded together, this is an element. It's the same all the way through it. So matter, again, it's either going to be a mixture or it's a substance. If it's a mixture, it's either homogeneous or heterogeneous. If it's a substance, it's either going to be an element or a compound. So let's look exactly at what an element is. An element is only made up of one type of atom. So here's a picture of a single atom buzzing around. It's an element. This is an element because even though these two guys are bonded together, they're exactly the same. So it's an element. This would be an element. It is 6 different atoms. Yes, they're bonded together, but it's still an element. A diamond molecule, for example, is made up of all of the same type of atoms. So it is an element. Gold, all made up of gold balls. So it's, or I should say gold atoms. So it is an element. Here's what it actually looks like on an atomic level. All of the same. Platinum. Platinum is an element. Here's what it looks like on the atomic level. All of the same atoms. Another element. Magnesium is an element. It's made up of all of the same atoms. There's the atomic view of magnesium. Sodium is an element. It's made up of all of the same sodium atoms. Phosphorus, this case red phosphorus, it's an element. It's made up of all of the same atoms. To be honest though, that picture is not red phosphorus. This picture is white, is a picture of white phosphorus. That would be my mistake. But whether it's white or it's red phosphorus, it's made up of all of the same elements. Or atoms, I should say. That's why it's an element. If you find it on the periodic table, the periodic table of elements, it's an element. There's 7 diatomics you need to know. Diatomic. Di means 2. So these all have 2 atoms bonded together. And in their natural state, this is how they come. You'll see the word elemental, in this case, hydrogen. You need to know that elemental hydrogen is always H2. Nitrogen. Elemental nitrogen is always N2. Elemental oxygen is always O2. Elemental fluorine, F2. Elemental chlorine, Cl2. Elemental bromine, Br2. And elemental iodine, I2. About those diatomics, is that there's seven diatomics you need to know. These seven diatomics make a seven, sort of. You have nitrogen, oxygen, fluorine, so that would be N2, O2, F2, chlorine, bromine, and iodine. Chlorine, bromine, and iodine. Now these make a 7. Interestingly enough, the atomic number of nitrogen is also 7. So you start at the 7, you make a 7, and if you're going, hey, wait a minute, that's only 6, you can't forget this geek in the corner, H2. Those are the 7 diatomics. You'll see them written as things like elemental hydrogen. You need to know that's H2, elemental nitrogen, N2. The different types of matter, the way matter's put together, you can have a mixture or you can have a substance. Mixtures are classified as either homogeneous, which is also called a solution, or an alloy if it's a bunch of metals, or it's going to be heterogeneous, different stuff. A substance is pure. You can either have an element or a compound. So now we're going to take a look at what a compound actually is. So a compound is more than one atom, different atoms, but they're bonded together. Bonded together. Different atoms bonded together. And chemically, we can break these down into its elements. For example, water. That's a picture of water. Water. You can break water down into its elements. Hydrogen always exists as H2, and oxygen is always O2. Water is now broken down into its elements. Of course, this chemical equation's not balanced, so I should balance it by putting a 2 here and a 2 here. Extra points if you can tell me why I needed those 2's. Remember, a compound is made up of 2 or more different elements bonded together. Make sure you have those words, bonded together. This is a compound. It's probably carbon dioxide, to be honest, but notice it has one atom bonded to 2 different atoms. That's what makes it a compound. This is a compound. It has more than 2 different atoms bonded together. 2 atoms bonded together, and they're different. Two different atoms, carbon and hydrogen, bonded together. It's a compound. Water. It's a compound. This is a compound. It has 3 different atoms bonded together. That's what those sticks represent. Those sticks represent bonds. This is called a ball and stick model. This is a compound. It has 2 different atoms, well, in this case, ions, but they're different, bonded together. With these types of matter, you're going to first have to tell me, is it a mixture or is it a substance? If it's a mixture, you have to tell me, is it homo or hetero? If it's a substance, you'll have to tell me, is it an element or is it a compound? Here we go. Substance or mixture? This guy is a substance. It's the same thing all the way through it. Is it an element or a compound? It is a compound. It has 2 different balls, atoms, fused together. Substance or mixture? This is a mixture, different things. Homo or hetero? It is hetero. Different properties in different areas. Substance or mixture? This is a mixture. It has different atoms, different properties in different areas. So does that make it hetero or homo? This is hetero. If I took a spoonful from the top, it would certainly look different than a spoonful from the bottom. Different properties in different areas. Substance or mixture? This is a substance. These are all the same thing. So is it an element or a compound? Those are compounds. They are made up of different atoms bonded together. Mixture or substance? Yeah, that's a mixture. Homo or hetero? It is hetero. Substance or mixture? It is a substance. So is it an element or a compound? Well, it's kind of hard to tell. My first guess is to say it's an element because it looks like different atoms just sitting together like in a solid. But you could make an argument, nah, you couldn't. It is an element because even if these guys were all bonded together, it's the same atom. So even if they were all fused together, it's still an element. Mixture or substance? Well, this is brass, and brass is a mixture. So does that make it homogeneous or hetero? It is homo. It's the same all the way through it. Do you remember the name for a solid solution like brass? It is an alloy. An alloy is a solid solution of metals. Mixture or substance? This is a substance. Element or compound? It is an element. Even though those atoms are bonded together, they're the same atoms. Mixture or substance? This is a substance. Element or compound? It's an element. You'll find it on the periodic table of elements. Mixture or substance? This is a substance. It's the same thing. That's all there is. Is it an element or a compound? It is an element because even though the atoms are bonded together here, it's the same atom. That makes it an element. Mixture or substance? I would call that a mixture. Homo or hetero? I'd also call that hetero because if you look in this area, it is different than this area, which is different than this area. Mixture or substance? Yes, it's a mixture. Homo or hetero? Yeah, clearly hetero. Different stuff. Mixture or substance? This is a mixture. It's a mixture of an atom and a compound. So is it homo or hetero? Well, I'd call this one hetero. You have different stuff in different areas. Mixture or substance? I'd call it a substance. Element or compound? I'd say element because you have all the same atoms in this picture. Mixture or substance? This is a mixture. It is also a solution. It contains water, probably, most likely, and something else to make it red. So if it's a solution, it's automatically HOMO. This one's a toughie. Look carefully. Mixture or substance? This is a mixture. You have one type of compound here. You have a different compound here. Homo or hetero? It is hetero. There's no even pattern. You have those are there and different things here. Clearly heterogeneous. Clearly right. Mixture or substance? This is a mixture. It is homogeneous. It is also called a solution. Remember I said this contains water and acetic acid molecules. Mixture or substance? This one's tough. You could make a case for either way. If you call this a substance, then what I would say is you have 1, 2, 3, 4, 5 different atoms that are stuck together like in the solid state, and 2 atoms that have sublimed into the gas state. So if it's a substance, you could call it an element. Now, on the other hand, if you wanted to call this guy a mixture, you could do that and say, hey, these are all bonded together, and that's one type of element, and these are a different kind of element. So you would have 2 different elements, and if you have 2 different elements, then you have to decide, is this homo or hetero? Well, then I would say it's hetero. You have to justify this one. Homo or hetero? Well, first let's start with mixture or substance. This is a substance. Is it homo or hetero? No, not right. If it's a substance, it's element or compound. Silly me. This one is an element. It's all made up of exactly the same type of atoms. Mixture or substance? This is a mixture. It contains this type of, this element here and a different element here. Remember, they're elements because the atoms, even though they're bonded together, they're the same. Would you call this homo or hetero? I'd call it hetero. Notice the bottom portion is different from the top. Look carefully at this one. Substance or mixture? This is a mixture. You have this type of atom compound here. You have a different compound here. That makes it a mixture. Homo or hetero? Well, again, I'd call it hetero because notice you have those 3 atom compounds on the bottom and the 2 atom compounds on the top. Mixture or substance? Well, this one's kind of hard to tell. I mean, it could be a substance if that was like solid platinum, then it would be an element. But in reality, this guy is a mixture. It is an alloy. It is a blend of different metals, and that makes it homo. Mixture or substance? Yes, this is a mixture. We've got dark balls and white balls. Homo or hetero? I'd say it's hetero. You have different stuff in different areas. It's not an even, uniform pattern. All right, guys, up next we're going to talk about how you separate a mixture.